Why wouldn't you help me with the electronics repair? You just want to go outside. Or do you want some snacks? Hmm? Do you want some snacks? Oh, such a good boy. Oh, such a good boy. Oh, always denying me affection. Right, so this is, apart from the front panel below it, and the top panel, this is largely reassembled. The earth wire I've reattached directly to the chassis. Filtration and rectification board is just sitting on this cushion, but apart from that, everything else is hooked up. Transport's working okay. Rewind is now working because I've replaced that belt. So the problem we've got is audio is reaching these three channels, these three VUs and the corresponding tape outs, but not this one. So signal tracing somewhere under there. There's a little pair of powered Alesis monitors, cable coming out of that. Here's my audio probe, which consists of a jack socket with a capacitor attached to it. The negative lead is attached to the chassis, and the positive lead I've wired to an old probe. So if I press play, then I can touch this to parts of the circuit and the signal will come through. You've got to think for operational amplifiers they might be up to positive or negative 15 volts at points. Capacitor on the probe should prevent that DC from doing anything. I suppose if I touch two 15 volt things together, then that might do something detrimental to the system. I would not go prodding this around here because the voltages are that much higher. I absolutely will not touch anything to do with the power socket or the fuse over here. I do want to pick points where I've got a reasonably good idea that there is going to be a signal. So we established before that the brown leads leading to this header here is where the play and record back head is. So in playback mode it should be coming in here, and another giveaway of that is this set of 4 relays. Relays in this context are usually used to switch whether that head is switched to the record amplifier or the playback amplifier. So the fact that that's over here near this socket tells me that this is the array system here and this is the record playback system here. I press play. I've got, just because it's my mum's old tape, I mean I quite like Leonard Cohen, but it's Leonard Cohen the future. It's the album. So a reasonable guess for me is that these 4 trim pots here are going to be part of the signal chain. So before I was filming that actually was working, let me figure out why that isn't. Okay, so this is roughly how the area is sitting in order for me to do signal tracing. I've been in there and done some signal tracing, and I've done a couple of stupid things. I want this channel to document my mistakes as well as my successes. I don't have any real electrical engineering background professionally or academically. I would like to think that I am like the people who are watching this channel, only maybe a few steps further down the road. So you can see the way that I've got this sitting. This is dangling, so I've still got access to these contact points under here. Obviously I can turn this around on the bench and look at the components from that side, get a sense of which contacts pertain to which components. You'll recall that there was a long plate along here to which this power filtration board attached, so I can't really access this PCB without leaving this dangling, so I've taped some foam around that so that none of the rectifiers or capacitors can short against anything, so I can't touch them when they're on. And that's great, but first mistake was I didn't do anything to tape up this power switch, and you can see that orange is connecting to the fuse. Basically that's the live wire. Yeah, so it's possible to touch one or both of those points, which I did. I got a 240 volt electrical shock. Fortunately it was my right hand. If I'd done that with my left hand, then maybe that would have stopped my heart. So next thing I'll be doing is taping that up. So for God's sake, if you're going to signal trace something with an internal transformer where it's possible to touch anything on the primary side of the transformer, be much more aware of where that was than I am, because I think I was just absent-mindedly touched like that. I must have hit one of these points. But ideally you want to cover any points like that with insulating tape or something before you even plug it into the wall. The other stupid thing I did is, I guess I was in a hurry to make the video. The little home brewed audio probe that I've been using for a while stopped working. So I put together this kind of jerry-rigged one. I'm not sure whether jerry-rigged is one of these post-woke things we're not meant to say, but I mean bespoke, improvised. So that's going into one side, my little powered monitors here. The negative side, I've got a crocodile clip, and that was connected to the chassis. Then the positive side of this is going to a 0.1 microfarad capacitor, and then the other end of that is the probe. So the idea is that DC is blocked by this little capacitor, but the value of it means that you're not really filtering out anything within the range of human hearing, and it works fine. The thing is that that's a much larger piece of metal than that, so the chances of bridging two contacts when you're probing is much higher, and the tolerance between a lot of these pads is quite small, especially like here. You can see that's like an SIP op amp, and I did that. I bridged some contacts and there was a little spark. And I mean, the thing is, if you touch a single DC contact, you might hear a pop through the speaker, but basically the speakers and the amplifier is going to be protected by this capacitor, at least to an extent. However, if you, by introducing whatever it is, 10 to 15 volts is the range of voltages that I've encountered going into the power inputs on op amps. If you send that into one of the audio inputs, there's all sorts of potential for unplanned currents to go through these delicate semiconductors. So the long and the short of it is, I've fucked one of the op amps that wasn't fucked before. And something I will guard you against doing in general, I don't have the service manual for this, as I've said. There aren't any annotations on either side of the PCB. Usually when I'm signal tracing, I've at least got some sort of sense of the anatomy of the electronics from looking at a schematic before I go in there. And this one I just didn't, so I'm not sure how wise or fruitful it was going to be for me to go poking around there in the first place. I mean, basically I had a problem with just this channel. I think beyond identifying this little square here and this little square here are the ones that are pertain to that channel, I will replace all those components. I'm not sure there's really anything else that I should have done. As it is now, I've got 2 fuck channels, so I've got that many more op amps to replace, transistors to test out of circuit to see whether they have appropriate voltage drop in them or whether they've been shorted or blown. Yeah, so I've just basically generated more work for myself. So this is Tetracan Super Monoblock. Tetracan Super Monoblock has been a fanny. Don't be like Tetracan Super Monoblock. Don't be a fanny.